Hello everyone. In today's video, we're going to talk about quantum computing because there has been a big, investor confidence in terms of quantum computing with the advent of Google's chips and new technologies and the stock price going up. So it's appropriate to do a video on the quantum computing, and at the backdrop what we'll use is AWS Braket because that is the cloud provider that has been using a lot of these infrastructure from quantum computers such as IonQ, Rigetti. So that is what we'll do as part of this quantum computing. So as always, please like, subscribe our channel. So without further ado, let's get started. So what is quantum computing? Essentially, quantum computing, it's a new way of processing information that uses quantum coherence and entanglement, has the potential to solve computational problems beyond the reach of classical computers using quantum mechanics. So how it works? Quantum computers solve problems fundamentally differently than conventional information processing. Instead of using traditional CPU and memory models qubits, or like QU, BATs, which is quantum bits, the building blocks of quantum computer are used to store and process quantum information. While quantum computers have the potential to be disruptive, we are still in the very early stages, hence there are significant and engineering challenges that need to be overcome before customers can use quantum computing to address business problems. And the same was also mentioned by Jensen Huang, that he mentioned that if we say quantum computers are around 10 years, it's kind of too early. If we say 30 years, it is too late. So 20 years is probably maybe the right time, though a lot of the quantum providers came and disputed his claim that we are still very production ready, but still there are not many use cases as of yet that have been using quantum computing for that matter because of the price, and it's very nascent as of yet, so it's still evolving, but we'll keep you updated on how the next steps are coming up. So while quantum, as I said, right, so there's significant challenges that need to be done. The potential is it could solve intricate problems in cryptography, optimization, drug discovery, and material science. And as I said, we have a lot of improvements that we could go under. So what is the promise of quantum computing? So you might wonder why a quantum computer can provide speedups for some problems, but not for others. And this is where quantum computing offers exponential speedups for specific problems over classical computers. It uses a differential computation model with unique algorithms. Few examples of quantum advantage. Integer refactoring is one to provide efficient classical algorithm but solvable efficiently with quantum resources. For active research, we have discovering new quantum algorithms as a key focus, and it's inspired by Richard Fennian's vision of quantum computers for simulating the systems. Richard Fennian postulated that the quantum computer is the best tool for studying certain classes of problems, aimed at simulating the physics of quantum systems. What are the applications? There are drug design is one, material science is another one, optimization, and more. And it has long-term transformative potential, and that's why so many people are paying attention to it. However, it is difficult to predict which verticals and industry use cases this technology will transform the most. By starting now, some of the more forward-thinking customers can understand the potential of the new technology and begin reaching and developing algorithms and applications. So what we'll do, we'll look into AWS Braket in this scenario and how we can check it out. So what I'll do is I'll go to the AWS console and quickly show you the AWS Braket here. Okay, so AWS has a service called Braket, which is, as you can see, it is B-R-A-K-E-T. And this is the quantum computing service that is there. If you come over here, we could also see an introduction about what exactly is Braket. You could service for exploring, evaluating, and experimenting with quantum computing. So it's a totally different service. It's not part of the EC2 that is there. So what we will do is we will see how we can use Braket and the infrastructure that is required for the setup. So if we come over here, it seems pretty like a simple GUI that you could see at the left-hand side. We see the dashboard, the devices, what could be done as part of notebooks, the hybrid jobs, quantum task, and the algorithm library. So what we'll do is we'll try to go with each one of these. Ticking is we could just do get started. And this is where we'll get a wizard that we can just create a service link route. I'll create one. And before you do this, ensure you have the right permission. That is, you do have access to Braket. You may need to talk to your administrators in your organization or you may need to request it via ServiceNow or any other process in your organization, so you have full access to Braket to be able to simulate the scenario. But create service link rule, and this is where you will be getting to the next step, which is hybrid jobs execution rule, which is optional. And here it mentions that you will be getting this policy that provides the minimum permissions required to be able to run a Braket job. And it offers a mechanism to run variational compute classical algorithms as well. We may not need it, but let's go ahead and create the role. Now this is where you could have enabled a third-party services, which is optional. It's recommended to do it to just simulate your integration, and that is what I think. We'll just go ahead and click it. Now this is where we could create a notebook instance. It's going to be required because a lot of the quantum computers will be, the work that we will be doing will be as part of the notebook. So here I could just type in Arina and let me do this. So it will, and here I could just do it hours, over here days, so let me just change it to 1 day. So that is essentially, it will attempt to stop your notebook after 1 day, so there is no additional cost incurred, and something you should be looking into, otherwise you can get to be running a iBill. So, and then you do create notebook, needs to be 7 days, okay, so we can't have 1 day over here. And this is where you create a notebook. And now we see the resources are created over here. And let me go and open the notebook. Now this is where we see it's still opening up. It's starting the notebook. It could take several minutes. And this is where once the notebook is started, we can come back again. Okay, so we have our notebook now created. And it did take around a good 5 minutes on an average to have it created. But this is where, we have it, and what we can do is we can get into check it out. We could also come here, notebooks, and what we also will look into is devices. So these are the available quantum computing devices which we have. You see we have IonQ available, and also it's kind of interesting that AWS has its own devices, SP1, TN1, Alpha, Anka 3. There are a few retired devices. Obviously retired devices are something you may not want to look into. You may just want to look at the latest ones. But these are the ones, and if you click on one over here, and you could see the details for the SP1, how exactly it is. This is a 34-qubit AWS vector simulator. You could do this in a notebook as part of the setup. And similarly, likewise, for each one of these, you could click one of the, fourth one, you could click it and check it out. So let's now go to the notebook from this section and open it up. And I hope you all are familiar with Jupyter Notebook, where we could do a lot of machine learning work. It's mainly used by data scientists. So something to look it up and be and it uses Python, a programming language that you should be learning. So we could clear the workspace. It does take some time for the workspace to clear and your notebook to come up. So let's give it a few minutes. Okay, so now we have our notebook launched, and as we could see, we have these options here: start on Braket, Qiskit and Braket, Penny Lane and Braket. So a lot of options in notebook, and console we have, and terminal also we have. So what we'll do, we'll click on the start on Braket option, and we could see we have this is a Hello World Braket tutorial where we could prepare a maximally entangled Bell state between 2 qubits. And then we can run a circuit on a local simulator and obtain the results. So this is where it's a very, very defined use cases that you could be using in qubits. There are not many applications to go about it. So, but if you have to you could kind of get this code here. You could try running it out and see how it will be behaving. And that is the good thing about notebooks. You could come here, you could simulate the code, and then you could test it out as well. You could check it out and play with it over here. And we could see you could have these options here. You could have these running options as part of the setup if you want to do it. So you can come here, you can check it out. This video was not intended to be a deep dive. Let me stop it and so that you can see. And also I just wanted to mention that over here, you could see the hybrid jobs that are running the quantum task as part of the setup. And there are different devices that are available. So I hope this was a very quick overview about using quantum computing as part of at least AWS, how with the service that is available, Braket. how you could spin up notebooks. It's a very simple setup, and the devices that are available as part of, like IonQ is one, Braket is coming soon. The retired ones does have the other options, and with this you could go about exploring if you have identified a use case that you can go about it. So with this, please like, subscribe, share our channel, and let us know any comments if you want any deep dive session going forward. Thank you and have a good day.